Hello everyone and welcome to a brand new video. Today I'm going to show you how to solve the LeetCode Pascal's triangle problem using Java. So what is Pascal's triangle? So Pascal's triangle is an algebraic representation of the coefficients used in the binomial theorem. So the binomial theorem is used to expand any binomial with a particular power. So like here is the notation here, and here are the coefficients that will typically be used here. So let's go ahead and go right here. These first ones can, I think this is much better. So I know this is a bit blurry, but I know this is going to show exactly the binomial theorem and how Pascal's triangle is related to it. So x, y, 0 is 1. So 1 is the first coefficient here. And then x plus y to the 1, it's 1 and 1, so x plus y, 1 and 1, and then x plus y squared, that's x squared plus 2xy plus y squared, 1, 2, 1, and then this next line is x plus y cubed is equivalent to x cubed plus 3x squared y plus 3xy squared plus y cubed. The coefficients are 1, 3, 3, and 1 in that order, and therefore the fourth row in the Pascal's triangle has the coefficients 1, 3, 3, and 1. Also, you can retrieve this by adding two terms in the middle. So for every two numbers in a row, you will add the numbers and then it'll go into the middle of the two numbers in a separate row. I think you should know what I mean. But anyway, let's get into the diagrammatical representation of this problem. So as you see, let's go ahead into the diagram. So we got 1 and 1, they're added up, and then we got 2. 1 plus 2 is 3, 2 plus 1 is 3, 1 plus 3 is 4, 3 plus 3 is 6, and then 3 plus 1 is 4 as well. Yeah, however, we're not focused on the dynamic programming aspect of this problem. We're just focused on the array, so this is nowhere near optimization. We will also have ones at the ends of each row, both ends, both the beginning and the end. Meaning that row 1 will have 1, row 2 will have 2 1s, of course, and pretty much every row will have 2 1s. So let's go ahead into the whiteboard demonstration about how to think of the algorithm here. So here is a representation of Pascal's triangle. I put this plus because you can just add up these two terms here. So these are the first 14 rows of Pascal's triangle. And notice here in the first row, we only have 1, 1, and then 2 rows we have 1, 1 with nothing here. We have 1, 2, 1, 1, 3, 3, 1. Notice here we got the 3 from adding 1 and 2. So that's why we got 1, 3, 3, and 1. The 1s will still be at the end. For the next row, 1 plus 3 is 4, and then 3 plus 3 is 6, and then 3 plus 1 is 4. And then 1s will always be at the end. Then there's 1, 5, 10, 10, 5, 1. Then 1, 6, 15, 20, 15, 6, 1. So you do see the pattern. Every time we add up the digits here, every time we add up the adjacent tiles, we'll get a result in which we can add it to the middle of each row. Now I say, since this problem requires you to return a list of lists, we're going to be adding a row here. And in order to save time, we're going to be using a linked list. But anyway, let's get into the algorithm here about how to return the first n rows. So I'm using this notation that I used in my discrete structures class. So with a procedure, and then let's say a return thing. This is similar to a function in Python. But yeah, this is not exactly it. So let's go ahead into this procedure. In Python, it would be def, and then we have Pascal triangle. Now this is iterative, not recursive. So n number of rows here will be taken here as a parameter. So first what we want to do is make the list we're going to return. So we're going to call it triangle. And then we gotta add to the triangle, meaning that we need to add the rows here, as well as we need to add all the tiles here, like 1, 1, 1, 1, 2, 1. So we're going to make a nested for loop. But before we actually make the second for loop, we're going to make a sublist called row, and then we're going to keep track by the previous sublist by, of course, setting a list to that previous row. You'll look more into it. So, okay, let's go into the syntax of the for loop. We're going to set it to I equals 1, or I equals, actually it's going to be I equals 0. Set the incrementer to I is less than n minus 1. The reason why is n minus 1, I tried doing n, but it turns out if I did n, it would just print an extra row. So that's why I did n minus 1. And then we increment all this by 1. Next we're going to make a sublist called row, and then add 1 to that row. We add 1 to both the beginning and the end, which is why it says twice. And then of course, we made the list here. Now for the nested for loop, we're going to make a for loop here. J is going to be equivalent to 0. This is where we add all these tiles here. So for example, if we want to get this third row from the second row, we're going to be, so J is going to be the indices of the previous sublist. So that's going to be 1 and 1. And we're going to add 1, 1. So notice here we're going to add 2 after 1. And then the for loop terminates. And then we're going to add 1 to the row, and then we add it to the triangle. Similarly, 1 and 2. For example, J could be 0. So J is 0 and J plus 1 is 1 actually. So that means 1 plus 2 is 3. And then the same goes for 2 plus 1, which is 3. 1. And vice versa for every row here. And then we're going to return triangle at the end. So that's the algorithm that we're going to do. So let's go ahead and make our triangle here. So list integer. Let's call it triangle, and we're going to set it into a new linked list. The reason why I did linked list is because we can directly add elements without overall changing the time complexity. So triangle dot, we're going to add a row of 1. So we're going to add new int this. And then we're going to make for int I equals 0. I is going to be less than numRows minus 1 I plus plus. And then we're going to make a subrow here, or a sublist. So integer. Actually, that's going to be just an integer list. Let's call this row to be equivalent to a new linked list. Next, we are going to add 1 to the row. So row.add 1. And then we're going to do it again here. But this time we're going to add a nested for loop. For int j equals 0, j is less than. We also have to keep track of the previous subrow. So list integer previous. We're going to call it previous. Then we're going to say triangle. To get something at a particular index, we use triangle.get. So triangle.get I. And then j is going to be less than previous dot size. This is how we get the number of elements in a list. And then not I plus plus, j plus plus. And then inside, we are going to add these numbers here. So 1 plus 1 is 2. So we're going to do a row.add. We're going to sum up the numbers. So that's going to be a previous.get j plus previous.get j plus 1. Oh yeah, honorable mention, I should have said it was minus 1. And yes, there we go. Next we can add the row. Now we gotta add the row to the triangle. So triangle.add row. And then we can return triangle right here. What am I missing here? I don't know. Looks like I added an int array rather than a list, so new linked list. So we're gonna make the first row here. So list integer first row equals new linked list. And then first row dot add 1. And then triangle dot add first row. Forgot to add a semicolon here. It turns out our cases have been accepted here. Let's go ahead and submit, and hopefully it should be good. There we go. So, guys, this is it for the solution. If you guys enjoyed, make sure to leave a like and subscribe, and see you guys in another video. Peace.